So hello guys, what's up? We are back again with another question and another series. This is our phase 4 stack and this is our first question from the phase 4 stack, which is minimum stack. So guys, what is this question all about? This question says that we have to implement a data structure or a stack data structure in which we can push any value, pop the topmost value, return the topmost value, and can get the minimum of the values we have pushed in, which are there in the stack, in a constant O of 1 time complexity. So how we can do that? So we can do that with the help of two stacks. Yes, we can implement this very easily using two stacks. Now how we can do that? Think of it like this. Okay, so one stack we will have it a normal implementation. So see, there is only one feature which we need to implement apart from the stack, which is get minimum in O of 1 time. Otherwise, push, pop, and getting the top was always in O of 1 time in stack. So only one thing we need was to keep a track of minimum elements. Now, one would say that we can keep a minimum element as a variable and then we can have. But what if you popped that? Then you need to search the entire stack for the minimum element, for the next minimum element to be your minimum element. That will take some time complexity. So it will not be in a constant time complexity. So how we can do that is by implementing it using two stacks. Now, what will the second stack do? Second stack will have the elements greater than or equal to the first element we pushed in. Yeah, that's right. You can think of it like, see, if it is the first element we are pushing in the stack, so if the elements are greater than the first element, then until and unless the stack is empty, we will not get them as our answer in the minimum. Okay, so we are only concerned about the elements which are greater, which are less than the first element you inserted. Those elements can only be the minimum element uh, in the get minimum function. So we will use that concept only. Okay, so let's see through that. Let's see the code so that we can understand it better. So we have implemented it two stacks, stack st1 and st2. Now we can have a push function. Okay, first we will check if st1 will be our normal stack and st2 will be our stack to maintain the minimum element. Now, if st1 is empty, we will push st2 as int max. So it has no element since st1 is empty. So naturally, st2 also have to be a very big element or int max. Now, if the value is less than or equal to s2 dot st2 dot top, as st2 dot top will have the minimum current minimum element. Now, if the element which we are inserting, which we are pushing, is less than that as well, so we need to push that into the stack. It will then become the next, the current minimum element. What if the value is greater than equal to s2 dot top? Then we need to do nothing. That minimum value, until and unless it is not popped out of the stack, will remain the minimum value. So we need not do anything in that case. We just need to push that into the normal stack. Okay, so pop function is very simple. Now we need to also check in the stack 2, if the minimum element is what we are popping, then we have to pop it from stack 2 as well. Otherwise, we just need to pop it from stack 1. Now int top, we will simply return st1.top, and int get minimum, we will simply return st2.top because it contains the minimum element. So yeah guys, this was the question. This was a fairly simple question. Thank you so much guys for watching this video. Just in case you like the video, like the question, make sure you hit the like button, press the subscribe button and share it with your friends. Thank you so much guys. We shall see you next time.